Problem number 5. If the electric field intensity is given by E is equal to x ux plus y uy plus z uz volt per meter, the potential difference between x 2, 0, 0 and y 1, 2, 3 is option A plus 1 volt, option B minus 1 volt, option C plus 5 volt, option D minus 5 volt. Solution is, we know that the potential difference is given by here x to y minus integration x to y E dot dl. So E dot dl is equal to how much? So E dot dl is equal to dx ux, that is x ux plus y uy plus z uz dot dl is dx ux plus dy uy plus dz uz. Here ux, uy, uz are unit vectors. That is x dx plus y dy plus z dz. So v is equal to minus integration x to y. That is x value is 2 to 1 x dx plus y value is 0 to 2 y dy plus z value is 0 to 3 z dz. That is equal to minus x square by 2, range is 2 to 1, plus y square by 2, 0 to 2, z square by 2, 0 to 3. So this is equal to minus, this is 1 by 2 minus 2, plus this is 2, plus this is 3 square, 9 by 2. So if you simplify this is minus of minus 3 by 2 plus 2, minus 3 by 2 plus 2 plus 9 by 2. So that is equal to minus 10 by 2 minus 5 volts. So answer D is correct. Next problem is, a system of 3 electrical charges lying in a straight line is in equilibrium. Two of the charges are with magnitudes Q and 2Q and are 50 centimeters apart. The position of the third charge is, the position of the third charge is option A 20.71 centimeters from charge Q. Option B 25.2 centimeters from charge Q. Option C 17.24 centimeters from charge Q. Option D 18.57 centimeters from charge Q. So this is a given problem. The solution is, here it is given a system of three electrical charges lying in a straight line. So three charges are on straight line, are in equilibrium. Two of the charges are Q and 2Q. So this is Q, so this is 2Q, and are 50 centimeters apart. So this is, the distance is 50 centimeters. So this is 0. Distance is 0. So total 50 centimeters distance between Q and 2Q. So the position of the third charge is 20.71 centimeters from charge Q. So if you observe options here, the distance is from charge Q only. So from charge Q, so another charge, suppose Q dash I want to calculate, is at a distance x. We want to calculate x. What is x? So here the condition given is equilibrium. So the three charges are in equilibrium when force acting on Q dash due to Q is, that is in this direction. Force acting on Q dash due to 2Q, that is in this direction. If the two are equal, then only that is the magnitude of the forces are equal, then only the three charges are in equilibrium. Therefore, that is, the force is F1, this force is F2. Then if F1 is equal to F2, then only the electrical charges are in equilibrium. That is Q into Q dash by, I am considering here magnetic parts only, Q into Q dash by 4 pi epsilon naught x square. This is the force on Q dash due to Q, that is equal to Q dash into 2Q, force on Q dash due to 2Q, 4 pi epsilon naught. So this distance, this is 50 minus x whole square. So if you simplify, I want to calculate x. So Q dash, Q cancels, 4 pi epsilon naught, 4 pi epsilon cancels, 50 minus x whole square is equal to 2x square. 50 minus x is equal to square root of 2x. 50 minus x is equal to square root of 2x. So you can calculate x easily. X, if you 1 plus root 2 common, is equal to 50. X is equal to 50 by 1 plus root 2. 50 by 1 root 2. Since 50 is in centimeters, so if you calculate this, you will get approximately 20.71 centimeters. 20.71 centimeters. So option A is correct. Option A is correct. That is, if you place a charge at a distance of 20.71 centimeters of Q dash, then all three charges are in equilibrium. Next problem is, an electric field on a plane is described by its potential. V is equal to 20 into r power minus 1 plus r power minus 2, where r is the distance from the source this field is due to option A monopole, option B a dipole, option C both monopole and dipole, option D a quadrupole. Here the solution is, here the field is given 20 into r power minus 1 plus r power minus 2. That is, this is 20 by r plus 20 by r square. 20 by r square. We know that, suppose a point charge is there. A point charge. So due to this point charge at a distance P, at a distance point P, this point charge is suppose located at origin. Or what is the potential? Potential, we know this. This is origin. This is at a distance r. The potential is, we know that, so this point charge is Q by 4 pi epsilon naught r. Q by 4 pi epsilon naught r. That is, due to this is a monopole. This is a monopole. So, due to a monopole, the field is inversely proportional to 1 by r. 1 by r. Suppose dipole means two poles are like this. Then at a distance point, this is r1, this is r2. What is the potential? So the potential is definitely, if you calculate, this is V is equal to Q by 4 pi epsilon naught 1 by r 1 minus 1 by r2. So that is this product V is proportional to 1 by r1 r2. Suppose if the two distances are equal, r1 is equal to r2, that is equal to r. So this is proportional to 1 by r square. 1 by proportional to r square approximately. So that is due to a dipole, the potential is inversely proportional to 1 by r square. So this field is because of monopole, this field is because of dipole. So we can say that the field is due to both monopole and dipole. So this type of questions are very important. We already discussed point charge. This is a point charge. Point charge or monopole. Monopole, E is inversely proportional to 1 by r square, V is proportional to 1 by r. Dipole. Dipole, E is inversely proportional to 1 by r cube, V is proportional to 1 by r square. So this concept is very important. Here directly they ask this concept. So we can say that this field V is because of monopole and dipole. So option C is correct. Next problem is, given an irrotational field F bar equal to K1 xy plus K2 z cube ax cap plus 3x square minus K3 z ay bar plus 3x z square minus y az bar. This is a irrotational field. Then del dot f bar at 1 comma 1 comma minus 2 is option A minus 6, option B minus 11, option C minus 7, option D minus 8. Just I am giving a hint how to solve this problem. In this, they are asking del dot f. Del dot f. That is, they are asking divergence. So first calculate del dot f. Del dot f is nothing but dou by dou x of fx component plus dou by dou y of fy component plus dou by dou z of fz component at a particular value 1 comma 1 comma minus 2. 1 comma 1 comma minus 2. That is, first differentiation with respect to x, y and substitute the values. If you simplify this, you will get k1y plus 6xz. After substituting the values, k1y is 1, k1 plus 6 into 1 into minus 2, minus 12. That is 6 minus 12. Sorry, k1 minus 12. k1 minus 12. This is a del dot f you will get. But k1 value we don't know. So k1 is equal to how much? Here it is given, it is a irrotational field. F is a irrotational field. Irrotational field means what? Del cross f bar is equal to 0. Irrotational field. Irrotational field. So make del cross f bar is equal to 0. Calculate the curl of f bar and equate it 0 and calculate k1 value. If you calculate, you will get k1 as 6. k1 as 6. So therefore, del dot f bar at 1 comma 1 comma minus 2 is 6 minus 12 minus 6 you will get. So you will get option A. Option A. So just calculate and verify your answer. Next problem is, do this problem as exercise. Medium 1 has the electrical permittivity epsilon 1 is equal to 1.5 epsilon naught farad per meter and occupies the region to the left of x is equal to 0 plane. Medium 2 has the electrical permittivity epsilon 2 is equal to 2.5 epsilon naught farad per meter and occupies the region to the right of x is equal to 0 plane. If E1 in medium 1 is E1 is equal to 2ux minus 3uy plus 1 uz volt per meter, then E2 in medium 2 is option A 2ux minus 7.5 uy plus 2.5 uz volt per meter. Option B 2.0 ux minus 2.0 uy plus 0.6 uz volt per meter. Option C 1.2 ux minus 3.0 uy plus 1.0 uz volt per meter. Option D 1.2 ux minus 2.0 uy plus 0.6 uz volt per meter. So this type of problems already we solved. This is a hint, just I am providing hint how to solve this problem. Hint is, this is a boundary condition. Apply boundary conditions. Apply boundary conditions. That is E1 tangential is equal to E2 tangential, D1n minus D2n is equal to rho s. Here rho s is equal to 0. So apply these two properties and calculate the electric field to E2 in medium 2. So if you calculate, you will get option C as your answer. Answer C. So just solve this problem and verify your answer.